Hey, this is the front-end web development class. My name is Jeffrey. We're going to start on our recap today, but as part of our recap period, I want to make sure that everyone's set up for today's class. There's not that much to recap that's really relevant to this class because we're basically just going to be talking about the command line and version control, which is not specific to web development at all. So I just want to make sure that everybody has followed the steps to set up. noisebridge.net/fwd/setup. Basically just go to this thing here and just follow these steps. Because today, you actually do want to follow step 3, and you might as well follow step 4. I should mention that for Windows, install Git for Windows with all default options. So if you are running a Windows computer, you're going to want to make sure that as you're installing Git for Windows, that git bash is checked, because you want to use a specific kind of command line, not the command prompt that comes with Windows for today's class. Otherwise, if you're on Mac, then you should just be able to type git, and it should just work. It'll probably install some developer tools to help you, get through the process. If you don't know how to open terminal, the best way to do it is via Spotlight. You just press the little, search thing and search for something, or you can do command space and just type terminal. Just in case it's confusing, I use another terminal called iTerm, so I'm going to be using iTerm. They're pretty much the exact same, so don't worry about the fact that I'm using iTerm and you're using terminal. They do the exact same thing. Yeah, so that's pretty much what I want you to do. Also, yes, please do sign up for a GitHub account. It's free, no credit card required. You can make as many free open repositories as possible as you want. We'll get into what repositories are, but essentially, you can continue to use GitHub for free as long as you make sure, as long as all of your code is public. That is to say, as long as everything that you upload can be seen by the world. If you want to get private stuff, that's how GitHub makes their money. Yep. So that's pretty much the setup. Any problems, questions, things about setting things up, or specifics? Well, cool. By the way, if it's not apparent in your terminal after you type git, you have to press enter. Every command that I talk about today, you'll have to press enter after you're done with it. That's a very simple terminal sort of thing. Yeah. Otherwise, we can basically talk about what we talked about in the last 2 weeks, although it's not really pertinent or relevant to this class. But, in case people want me to go through it, this is the time for me to do it, since we have the time. So yeah, before I start, does anyone want me to recap anything specific? I can also answer questions about anything. Think of it as an extension of lab time. Happy to do it. Yes? Yeah, what's up?
So in the homework, there was one and where you had to have 2 selectors, and the solution was that they are right next to each other with no space.
Right. So yeah, you were saying, let's see. Add a rule. Let's see. Hold on a second. Add a rule that sets the color directory elements of the class style to that are inside elements that are both. Yeah, so it's number 10. Add a rule that sets the color to blue for elements that have both classes style 1 and style 2. So the way what that selector looks like is this. When you write CSS selectors, you should think of anything that doesn't have any spaces in between it, referring to the same element. So that is to say, like, if I did this, and my selector looked like this, then what I'm saying is look for an element with the class of style 2 that is inside another element with the class of style 1. Think of it as sort of like traversing down a hierarchy of elements. That might sound very wordy. Basically what I'm saying is you start from the top and you go inward. You say, look for style 1, and then look for style 2 inside it, and then apply this class, right? So that's what this space means. In selectors, when you have a space, you're basically separating the kind of hierarchy, like the ancestry, essentially, of the elements. You start at style 1, then you look into style 2, and that's where you apply the class, the one that's furthest into this little, whatever you want to call it, nest thing. But if there is no space, then that means you're referring to the same element. So essentially, if you want to select something that only has both of those classes, I'm sorry, that not only has, but that has both of those classes and does not only have one of those classes, then you do this. This is going to make sure that the selector is only going to apply if it has this and if it has this, because you're just kind of mashing them together right next to each other. You can take this even further. You can basically say like div, or let's look at an element we talked about, li.style1.style2. This is basically saying find an element, an li element with the classes style1 and style2. You can tell that because this doesn't start with a dot, right? There's no dot at the beginning, which means that you're selecting an li element. And then everything following it goes .style1, .style2. Of course, if you think about it, the order actually does matter in this case because the element name has to come first. Otherwise, it would look like style1, style2, li, right? Which doesn't make any sense, right? So the element comes first because there's no little thing at the beginning like a dot to distinguish what kind of selector it is. And then it follows along with class selectors, and then I think ID selectors go in between, but we don't use those, so it's not a big deal. Yeah?
You can only have one element that you are selecting at a time.
No, you don't have to have that. So if you wanted to select, for example, an li that had a class of style1 and style2, or like a paragraph that had a class of style1 and style2, it would look like this. So you could say li with the class of style1 or style2, or this is pretty much an or because it sort of makes it so you can have two selectors for one rule. So this comma just separates the selectors, and this says or a paragraph with a class of style1 or style2. There's no way to sort of really kind of consolidate that. There's no way to make that easier to write. At least not in CSS. And there are other languages that turn into CSS when they reach the browser, like Sass, that make it easier to write. This is not valid CSS, but like something like this. lip.style1.style2. This is the same as this above here in Sass. So as you can see, like this little ampersand kind of just like expands these two things and makes sure that that rules apply this way. But can't do it. CSS doesn't support it. So if you want to select two elements, you can do that. Or you can just select any element. You can just say style1.style2. I don't think I've ever run into any circumstance in which I only want to select P elements or LI elements that have those two classes. Like where I couldn't just say select any element that has those two classes and make it a lot simpler, right? So usually I try to stay away from element qualifiers in the first place. I usually try to stick to classes because if you think about it, you're kind of like restricting yourself a little bit when you specify a specific element. Down the road, you might want to say, oh, this list item is better as a paragraph, or this div is better as a section, or something. Then you have to go back and change your CSS also, unless you're just using classes. So, from a real-world perspective, I only really ever use element selectors when I want to sort of change the way an element looks around the entire page. Like, for example, if every ordered list and every unordered list has that little bit of padding on the left that kind of pushes out each item to leave room for bullet points. But I might not want that on a certain site that doesn't really use list items for like bullet points or numbers. Instead, it just kind of uses them for like more kind of lists, like a list of your emails, or a list of something else that isn't really like meant to be prefaced with a dot for everything. So I would probably then just say like ul list style none, which gets rid of the dots, right? And I would also say something like padding 0, and that just applies across the entire page, which is great. So I don't have to like apply it to specific things, unless I want to say like something like plain list. Then it doesn't matter if it's a UL or an OL or anything, as long as I apply that class to whatever element I want to have a list style of none and a padding of 0. So, there's all that. Cool, yeah, so good question. Any other, do you need any, I know that that's a lot of like sort of specifics. Is there anything else that's not clear about that? Does that kind of make sense? What the difference is?
Yeah, it was funny though, when I was doing the exercise, for some reason, I think I put a comment space in between instead of just putting them together, and it changed everything. So, that just one mistaken rule affects the whole.
Well, it could if the rule is, say, missing an ending bracket or something like that. I mean, if you miss a bracket, then everything underneath it is like kind of part of that thing. Like if you did something like this, and then you say, you know, whatever, you know, then you notice that you're missing an ending bracket here, and so everything following after this is not going to be even like red. Basically, it's just going to stop there and go like, oh, I've done all I can, you know. So that could be one reason, but another reason could be, you know, well, you're applying style 1 and style 2 to most elements on the page, right? So when you're doing this, you're saying select anything with a class of style 1 or anything with a class of style 2, and that's pretty wide ranging, you know. It doesn't have to have both. It could be one or the other. So that's what this one means. Whereas this means it must have both. And this means this must be inside that, you know, within that element. So, yep, little differences, but they mean a lot. So just to recap. So like this means, you know, right? So that's the difference. Cool. And that's pretty much kind of like 1/2 of what we talked about in the previous class. So it's good to know. If it doesn't make sense at this point, make sure you start to understand it. The other half of what we talked about, by the way, I should just double check that at this point people have installed GitHub, or sorry, Git, and signed up for GitHub, 2 different things. Please go ahead and do that if you're not doing it already. Of course, the other thing we talked about last week was margin and padding and border and things like that. Let's take a look at this page and see what sort of margin and padding and stuff we have on this page. Because you can do that on any page you want, right? So here we've got our H1 element, our heading, and it's got a little bit of green above and below it. And this green is padding. Turns out that I applied where did I do this? I applied a padding top of 0.5 and a padding bottom of 0.17. Actually, I didn't apply this. This actually came with the wiki style for the rest of the site, but I decided to stick with it. So 0.5 and 0.17 what does that even mean? What's m? M means it's a unit that refers to the height of a line or the font size essentially. So when you say 0.5 you're saying half of its font size. So this H1's font size is 75 pixels, and so the top is going to be whatever half of that is, 37.5 pixels. 37.5 pixels. Yeah, there you go. Good. I did math. And then the bottom is going to be, you know, 0.17 of that, right? So 17% of that. You know, so that's one thing. Let's see what else. This hero H group or heading group has a padding of 40 on all 4 sides. See, it just says 40, so that means it's going to be applied to all 4 sides. So you know, you scroll down and eventually there's the end of that, right? Let's look at some things that have some margin. This H2, for some weird reason, has both padding and margin. There's not really a good reason for it. It's just simply because I think I probably just didn't get rid of the default padding on this heading that was prevalent throughout the rest of the media wiki instance, that is the rest of noisebridge.net. But then I probably added additional margin to the bottom, maybe, possibly, I don't know. Either way, it says right here that H1 and H2 should have a margin bottom of 0.6 m. So that's why there's that orange space in addition to the padding, which is 0.5 and 0.17 above and below, right? So there's that. Let's see here. I made it so each one of these sections. So this is where classes start to come into detail, into play. You see how this div has 3 classes: section, details underscore detail, and details underscore detail dash what. These are 3 different classes. don't get too confused about the underscores and the dashes. That's just my personal naming convention. It's a stylistic choice I've made. It doesn't say anything about what you should do with CSS or what you should do in your HTML. But as you can see, there are 3 things. Now, don't get this twisted with selectors. These are not selectors. Where I was talking earlier about, you know, this sort of thing where there are spaces, meaning that this is inside that. These are not selectors. These are simply lists of classes being applied to this element. This is the sort of stuff that you'll see inside CSS. This, on the other hand, is HTML. So when you see stuff like this inside your HTML, as a class attribute with spaces inside it, that means that 3 classes are being applied to the same element. So why are 3 classes being applied? Why couldn't I have just applied 1? Well, because I want each one of these to have a class of section. I want each one of these to have a class of details detail. But I want each one of these to have a different class, like what, who, when, and where. Right? So I have some rules saying that any section on this page is going to have a padding of 2n on the top and the bottom, and then 0 on the left and the right. And it's going to have a text align of center, although in this case it is crossed out because I probably undid that with this one here. Yeah, so sometimes you'll write a very general rule like section. Why is this general? Because you'll find that section will pop up in a lot of other places on the page. Section, section. These 2 are sections as well. This is a section. This is a section. And this is a section. Why did I apply section to all of these? Because I want all of them to have the same padding on the top and the bottom, and I want all of them to be center aligned, except for these 4, where I still want the padding on the top and the bottom, but I actually want them to be aligned to the left. I don't want them to be centered on the page. So that's why I decided to go ahead and use section, because I wanted to get as much benefit out of like not having to repeat myself and use these you know, this padding measurement in multiple places in my CSS file. So I just applied the section class to a lot of places, and now I have detail, which is sort of further fine-tuning these 4, where you'll only find them these 4 times on the page. And going even further, I have a rule that says that something with a class of details detail what, or something with a class of details details where, will have a background and a color of purple purple, right? So that's why these 2, what and where, have purple, and these 2 have green. So let's take a little closer look at this, because it's kind of hard to read. First, this says page-frontend web development.action view. This is saying that there is an element on this page that has 2 classes. It has a class of page-frontend _web _development. It also has a class of action view. So if you scroll up here eventually, you're going to see something like, where is it? Is this it? Yeah, there we go. Page-frontend web development. It also has a class of action view, and it happens to be the body tag. But I don't need to specify that. There's no need for me to. And because it has these 2 classes, I can then write some rules where it's only going to apply to details detail. If someone else wrote a class called details detail somewhere else on this site, it probably wouldn't apply, because it's probably the case that only this page has the class name of front-end web development, right? Wouldn't that make sense? So that's how I was able to write a CSS rule that actually applies across the entirety of noisebridge.net. I don't have the permission to make a specific style sheet to apply to this specific page, but I do have the permission to write a style sheet that applies to the entire site, which is kind of funny if you think about it. But anyway, I made sure that that every rule that I wrote about specific things on this page only apply to this page by writing this thing at the beginning of every rule. So you can see this space here meaning that anything that follows after this means that it's going to be inside it, right? And then finally, I'm selecting a class of details detail, right? So even though this is a little hard to read, it actually uses all 3 sorts of concepts that I talked about with selectors, right? It uses commas, it uses spaces, and it uses cases in which there's more than 1 class on the same element, right? So, this is the sort of the reason why CSS is powerful, why it's extensible, why I can use it in multiple places on the same page or across the site or whatever else, and not have to apply a different set of styles to every single element on the page, because that would be very painful. Yeah, so there's that. Really quick, I just want to check. No questions online, no viewers online either. That's all right. Yeah, what's up?
Is there a reason why you use a div tag instead of a section tag on the section?
That's a very good reason. Very good question. No reason specifically. You know, I thought I did at one point. I wonder why. I wonder if I stopped for some reason. Are there any sections on this page? There must be a reason for that. Maybe divs are special in some way or something like that. Oh, you know what I think it is? Let me think about this. So first of all, okay, yeah, there are no section elements on this page. The reason for that, I think, is because if I were to use a section tag, there was the very slight chance that older browsers wouldn't render it properly. The section tag is relatively new. It does kind of the same thing that div tags do. By the way, this is kind of beyond the scope of the class so far. I haven't even really talked about divs. Well, I'm sorry, the assignment had divs, so forget that. But yeah, divs are essentially plain elements that have no meaning. Sections are elements that act the same as divs in that they are just block elements with no other special powers. They don't have any padding, they don't have any margin, don't have any special significance, other than the fact that they sort of are meant to define a new section on the page, sort of a new, like, just component, new area on the page. Like, you know, so yeah, I could have used an element of section as well as maybe a class, just to be sure, you know, wherever you see the class section, but I probably did it just to maintain compatibility with much older browsers. I also could have put a rule in the style sheet forcing those older browsers to render sections properly, but I didn't. So yeah, good question though. I don't know, especially I can't give you a 100% accurate reason why, but I think that's probably why I did it. Yeah, cool. So there's that. Cool. So yep, just another reminder: get this all set up, because despite everything that I've been talking about during the recap so far, none of this is relevant for today's class. All I'm doing is talking about Git for today's class and the command line. So if you're like a pro with Git and a pro with the command line, you probably won't get much out of today's class, but you know, maybe you'll get a little refresher, because that's pretty much all we're talking about. The reason I'm talking about it, you know, at the beginning, sort of like taking a hard turn from talking about HTML, CSS, and JavaScript, is because I think that it's important for anybody writing any code of any kind to understand how to use version control. I'll explain what it does in a few minutes, but you know, like, just sort of the reason I'm structuring it this way is because I think getting this out of the way sooner rather than later will help you out, not only within here, but just from a coding perspective in general. Talk about what GitHub does and how to use it and all that stuff. Cool. Any other questions, things they want me to go over? Assignments, previous lectures, whatever else? Yeah, sure. No, go ahead, please. Yeah.
I'm getting all these terms and stuff, so class and element, what's the difference?
Yeah. So elements, of course, are each one of these things with the brackets and everything that opens and closes and has stuff inside it. That's an element. So here's a div element, here's a div element, here's a div element. Div element. You can tell that because it says div right at the very beginning of the tag, right? So, you know, this div, you open it up, and it's got some stuff inside it, and then it's got a closing tag. So opening tag, closing tag. This entire thing, though, is a div element. So classes, on the other hand, are simply words that I put inside this class attribute that I can apply to any element that I want. So why do I do that? Because, as you can see, there's a lot of repetition with elements. Each one of these is a div, 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 div. A lot of divs. And it would be kind of foolhardy for me to write a rule that made all divs look a certain way, because it's such a versatile element and it's used in so many different contexts that applying a style to everything across the board, selecting a div by the element named div in my CSS would have very wide-ranging effects, right? It would style every single thing, and I might not want that. So by applying classes, I'm not restricted to the limited amount of element names that are available in HTML. Instead, I can apply any class that I want. MWJump, that stands for MediaWiki Jump, I think, and it's just made by whoever coded MediaWiki, which is the wiki software behind noisebridge.net. You can call them whatever you want. You can type in any class name at all, which is why in the homework I said style1, style2. I mean, those are just arbitrary, completely arbitrary. But the fact that you can call them whatever you want, the fact that you can, add a whole bunch of them to every element means that you're not restricted to only selecting divs or only selecting H2s or only selecting paragraphs. You can apply this class, this section class, or multiple classes to whatever elements you want, and then you can write a rule that makes them all a certain way. It's really cool. I mean, it just makes it so like write one thing, apply it everywhere, and it just works. So that's why I like to write CSS rules that select classes instead of elements. So when you see something like this, it doesn't matter what the element is. It doesn't matter if it's a div. It doesn't matter if it's an H2 or a paragraph or a list item or any of those things. As long as it is a class that has an element with a class of style 2 inside another element with a class of style 1. See? So that's the difference. That's the difference between elements and classes.
So class is the way to narrow down or pinpoint a certain type within that.
Yeah. Exactly, yeah. I mean, it's a way for me to categorize, essentially. Like, I can basically say that each one of these elements is of a class of so-and-so, and I do that for the express reason of writing CSS that will make them all style the same way. And making it so I don't have to write a lot of CSS rules that say, like, the first div on the page looks like this. The second div on the page looks like this. I mean, like, you can do this, but it would be ridiculous. What if you added another div in there or something? Like, you got to find you have to have a way to distinguish elements from one another, and you use classes to do that. So yeah, that's why. Yeah.
You can have classes and divs, but can you have divs and classes?
I don't see the distinction.
Can you have classes? There's not a class tag.
No, there's no class tag. Nope. A class is an attribute, it's not a tag. And yeah, even if you had a class tag, you wouldn't have a div attribute like div equals something. No, you can't do that.
Understanding if I have to open or what's happening, it's like not bringing anything up.
Well, if you can tell that you have Git by going into your terminal and typing Git. And if you get this command about usage, then it means you have Git installed. You don't. All right, yeah. So as you can see here, get Git on Mac OS, you just type Git, and it should install it for you. Or, does it just say command not found, or what does it say?
Oh, it's
Oh no, I'm sorry. That's not your terminal.
Oh,
You have to open up your
so
terminal.
type
first.
terminal where you type Git.
Oh,
Yeah.
sorry.
Yeah, open terminal and type Git.
Oh, just the terminal.
Yeah.
Yeah, sorry, I did cover that earlier, but I don't think it came in yet. No problem. Yep. Cool. So yeah, if Git is installed, you should see a command that looks. You should see a response that looks like this when you type it. By the way, like I mentioned, if you're using Windows, you're going to have to install Git from a website, and you'll have to make sure you install Git Bash as you do that. So just all the default options will work when you install. I probably don't need to tell Linux users how to do it because they probably already have. You're probably already using Git one way or another. So there's that. Cool. Let me see. Still, one viewer. Cool. Any other questions before we get started? Other sort of stuff. Things mostly make sense, kind of. If they don't make sense, that's cool. The only thing from a code perspective I'm going to talk about today is Git itself and the command line. Beyond that, we're not really going to be writing any HTML, CSS, or JavaScript at all, even when doing like little demonstrations of how all this code works. So if you're already daunted, don't worry. All the knowledge you've gained in the last 2 weeks is unnecessary for this class. cool. I think I might as well get started. So, oh. Hi, Brian. So PowerShell is not Bash. PowerShell, well, it's a good question, especially because very soon Windows will ship with a Linux subsystem that allows you to run a lot of the same commands. But I'm not really 100% sure how that works yet. So PowerShell will not really allow you to do all of the same commands that I'm talking about today. Whereas if you install Git Bash and you go ahead and you open up the Bash terminal there, then you can run all the commands that I'm running here. There might be slight OS differences, but I would not recommend using PowerShell just to follow along with this class, since it might be a little confusing. You can use Git with it. All that said, though, but I'm not going to talk about setting that up as part of this class. All right. Cool. Let's do it. Hi, this is the Front-End Web Development class. My name is Jeffrey. Today we're going to talk about Git and the command line. I haven't even really talked about what Git is. I'm not going to for a little bit, because the first thing we have to talk about is what the command line is. So, you've probably seen, you've probably seen cool movies where you've got some guy hunched over his computer in really thick rimmed glasses going like this. Yeah, it's a pretty cool website. That's coding. But you probably saw that with that's called hackertyper.com. It's pretty funny. Yeah. Or hackertyper.net or whatever. Hackertyper. Yeah. The reason that people use command lines or use terminals, kind of the terms are pretty much interchangeable, is because they want to be able to run small programs that operate on certain files on their computer. There's nothing that you can do in a terminal necessarily that you can't do in a more graphical user interface like Finder or Explorer or File Manager or whatever else. But I like to use it in this case because it gives you a little finer tuned control over what you want to do to specific files and how you want to navigate through your file system, and just kind of keeps some distractions away. And there are also some programs that you'll find have no graphical components. So, you're probably used to applications like, oh, look at all my applications. I can double click on one of these things and a window will pop up and I can start using it. But not every application necessarily has a graphical component associated with it. A lot of it is really just like printing out text when it runs. And so you can't really see anything unless you use a terminal to see that sort of output. So what sort of commands am I talking about? Well, one of them is Git. Again, I'll talk about what that does in a second. But the first thing I'm going to talk about is a number of different commands that you can use to navigate through your file system. So just really quick, I want to make sure that everybody understands really simple terminology. When I say file system, I'm of course talking about the files on your computer. This might sound silly to some of you, but to others, you might be new to laptops or new to managing files on computers, because a lot of people nowadays only use tablets. A lot of people nowadays only use their phones, and that's completely fine. It's just that a lot of programs have their own ways of managing your photos, your music, or whatever else, or different kinds of things. When it really comes down to it, though, these are files, and a more traditional laptop computer or desktop computer will have a number of different files and folders that you can navigate through, and you can sort your own stuff out, right? The terminal is yet another way of just being able to navigate through your system. At any given point when you've got a terminal open, it's operating within the context of a specific folder on your computer. That is to say, if you open up your terminal and you type in pwd, you're going to get a little thing in response. pwd stands for Print Working Directory. Directory, otherwise known as folder. Essentially, your working directory is wherever the other commands that you type into your terminal will take place. So, for example, if you want to operate on a file in a specific folder, the first thing you need to do is navigate to that folder so you can more easily run those commands. So pwd will first tell you where you are. By default, when you open up your terminal, you'll most likely end up in something called users/so-and-so, or sometimes home/so-and-so, which is your username. Sometimes it'll say users/so-and-so's computer, or something like that. But that is your home folder. It is equivalent to this folder right here. This, like if you're in Finder, or even if you're in if you're in Windows, by the way, you go to c/users/your username. You'll be in a very similar folder. It's got documents, it's got movies, it's got photos, it's got other sorts of things, music, and this one does too. So they're very similar in that respect, just in how they're all laid out. But there's no C drive on computers other than Windows computers. But anyway, the next command that I want to show you is like, okay, great, I know that I'm within a certain computer. I'm within a certain directory, but what's in this directory? What can I actually do? Which files am I nearby, essentially? So you can type ls. ls is short for list, and it just lists out the folders and files in your current folder, in your current working directory, the one that you're currently in. It looks like I've got a lot of stuff in my home folder. So there's that. I'm sorry? Stands for list. Yeah. So the two commands so far are just pwd and list. That's enough for you to be able to know where you are and see what's around you, right? So the next thing we want to do is be able to move around. So we're done with this home folder. We want to go ahead and navigate into somewhere a little bit deeper. So I'm going to go ahead and go into cd space downloads. So this command here is more than just a single word like pwd or ls. It says cd, and then it's the specific name of the folder I want to go into. CD does not mean like CD-ROM or something like that, so don't think of it that way. It means change directory. CD stands for change directory. And whatever directory you specify will be the one that you'll be going into. So, choose one from up here. Some of these are files, some of these are folders. On my computer, the folders are highlighted in blue and the files are highlighted in white. That might not be the case on yours. That's okay though. If you want to, I don't know, there are ways to find out specifically what's what. Sometimes if you cd into something that isn't a file, like test.php, it's going to say not a directory. So try something else, right? So cd downloads. Okay. So now it's telling me I'm in users/jeffreyw/downloads. What's more, my terminal's got a cute little thing that I spent some time on that colors it really nicely. It tells me which directory I'm already in, so I never have to type pwd myself. It says what my username is at which thing. By the way, if your terminal says something like username at and then something you've never seen before, chances are it's because you're on the Noisebridge network, which does funny things with host names. Chances are if you have connected to the network and you're sharing the same private IP address that somebody else had when they connected to this network, you might be given the host name of that computer. So if you see something like Joe's Android or like so-and-so's iPhone on your desktop, don't be worried, you're not being hacked. It's just a really weird quirk of Noisebridge, and I don't really even know if it's intentional or not, but whatever, either way, so don't worry about that. But now that I'm here, I can go ahead and, pwd, right, I'm here. I can say ls, what.jpg, let's find out what that is. Oh, great, it's my cat. Cool. But yeah, so, right, open is one command that's only specific to Mac OS. I think that if you want to do that in Windows, you probably have to type like Explorer something instead. If you are using Git Bash, you can probably type Explorer space some sort of file, and it'll probably open that file up the same way that Windows Explorer would open it up. By the way, when I say Windows Explorer, I don't mean Internet Explorer. I mean your file manager. They might not even call it that anymore. So I'll just try to say file manager on Windows from now on. Anyway,
Edge, but
no, what? Edge? Yeah. No, I'm not even talking about Edge or Internet Explorer. I'm just talking about your file manager. But yeah, right. Can we do that? Can I say Chrome? Nope, Chrome's not a command. No, there are some apps that have both graphical and command line interfaces. So you can open something up, or you can also just like, for example, if I wanted to open up a certain file, PHP, using Sublime Text, I personally can type subl, which is short for Sublime Text, and it'll go ahead and open it up in, oh, look, I write but a lot, I guess. It'll open it up and actually take me out of my terminal. So, there are certain commands that can do that. You can open them up from there. So far we have the ability to navigate into folders. We have the ability to list out folders and find out where we are, and even open certain things, or open them the same way that that would happen if you were to double click on them. Yeah?
What's the ls command there?
List. So it lists out what's inside your current working directory. So as you can see, my current working directory is user/fw, and ls lists everything out. So yeah, I'll talk about that in just a second. But one more thing is that what you should know is that, of course, when we're talking about folders, we're talking about the fact that you put folders inside folders inside folders. There's a big structure. There's a big file system structure. And so these slashes essentially connote that you are inside a folder that's inside another folder. Whenever you type pwd, you'll get the full hierarchy of folders all the way to the root directory, which is just known as slash. So we're starting with slash, users, then Jeffrey HW. That's kind of how it all goes. So let's say that you went into downloads and you're stuck now. You don't want to stick around in downloads. You want to go back to where you were, or you want to go up one directory. You can think of going into a directory such as going down. You're going further down into the, down the tree or something. Or if we're thinking about a tree, it's more like up the tree. But either way, you're going further down into the stack of files and everything. If you want to go back up, then you can do cd space ... Anywhere with any command that you write, whenever we say dot, whenever you see ... just 2 dots, it means parent directory. So essentially, cding into parent directory means that you're going back up. You're going back to where you are. So now I'm back in users/fw. You can keep going, by the way. cd space ... Now I'm in users, cd ... Now I'm in slash. My current directory is just slash. I'm at the very, very top. I try to go any further, same thing is just going to happen. I'm still in slash. What's in slash? Oh, some really, specific network, like deep down computer stuff. Stuff that you shouldn't really mess around with. I would recommend, by the way, that if you are creating any files or folders or whatever, that you start at your home directory and try not to go outside of your home directory. There's barely ever a reason to do anything in any other place than your home directory. Because that's usually stuff that's managed kind of by your operating system. So pretty much everything here that isn't users, you should usually stay away from. That's just my recommendation. And a lot of things you won't even have access to. I'm not going to get into things like access control when it comes to running certain things or navigating into certain places, but you might need to enter your password to do certain stuff, depending on which folder you're doing it inside. But if you do it inside users, then you don't really have to worry about that, or user / whatever your name is. Now let's say we want to go back into users. We have a few, we're back into my home folder. We have a few choices from my root directory. I can type in a full path. So here I'm starting with slash, and then I'm saying users, and then I'm saying /ww. If I start my cd command with a slash, that means that I'm specifying an absolute path. No matter where I am in my system, no matter how deep into a folder or how shallow into the root directory I am, if I start my path with a slash here, then it's going to take me away from wherever I am, not worry about where I am relative to the folder I'm going to next. It'll just take me directly there. So I can do the same thing with like cd/, all of a sudden I'm back at the root directory again. So that's the difference between going like just the name of the folder instead of going like the full path. If it starts with a slash and necessarily and potentially has like multiple slashes following after it, that means you're referring to a specific place within your whole file system. Cool? But I might not want to have to keep typing in my full home folder all the time. So there are two things I can do. First thing I can do is type cd tilde. Tilde, this little squiggly line, shift backtick, is basically a shortcut. It's shorthand for your home folder. So if you're anywhere and you want to go back to your home folder, you can do cd space tilde, and it'll take you right back there. Here we go. I'm back here at my home folder. How does it know what your home folder is? It's based on who you're logged in as. Since you're logged in as Jeffrey HW, that's me, then it's going to take me back there. That's the specific home directory. And even better, let's go back to slash or something. I actually can omit that tilde entirely. If I just do cd, just the word cd and nothing else, it'll take me back to my home folder. So this tilde is really only useful if you want to say like cd tilde slash downloads, or let's say instead of cd, let's do open downloads tilde slash download slash but.jpg. Right? That's going to be my home folder slash download slash picture of my cat. Right? So that's what that means. So whatever this starts with, if it starts with the tilde, you're referring to your home folder. If it starts with a slash, you're referring to the root directory and then whatever's inside that. And if it starts with neither of those, it just starts with a folder name, then it's relative to wherever you currently are. And this stuff is actually pretty useful for web developers because when you write HTML and you use hrefs and you use sources and you use different sorts of things to refer to your CSS files or refer to other places on the web or refer to other places on your server at least, the same rules apply in most cases. I mean, not tildes, but slashes and relative things like, the slashes work pretty much the same way. So if you wanted to refer to a CSS file or an image file that was a few folders deep from where your HTML file currently is, then you could use the same sort of thing inside an href and it would work the same way. So, that's something worth knowing about. Okay, so back in my home folder, cd. Let's see, what else do I want to do? Let's talk about creating new files and creating new folders. To create a new file, all you have to do is touch test.text or something. Touch creates a new blank file. By the way, a lot of commands don't provide feedback. They don't provide operation successfully, executed or something. They don't actually give you back any sort of sign that the last thing worked properly. The way that command lines work is that if you get no response, then it is expected that the last command succeeded. So that means terminals are going to be as I'm trying to find the opposite of verbose. They're not going to be verbose, okay? Even though you didn't get any feedback from running this thing, if you didn't get any like error, access denied, or no such file or directory or something like that, then chances are it worked. So let's see. If I do an ls, I should be able to see test.text. There it is. See, it's been created. If I go back over to Finder, then I should see it too. There it is, right at the top. And I can open it up. It's blank. Just a blank text file. And that's great. If you want to edit files from the command line, you can use Vim or Emacs. If you want to create a folder, sorry, I just thought I'd mention. Editing stuff from within a command line, like editing files, people definitely do that. You talk to people around the corner here, like we're behind me in Python class or at Circuit Hacking, or just people who hang out at the space regularly. They can go on for literally days about how much they love their command line based text editor. I don't use one because I think it's a waste of time. So like if you like Vim, if you like Emacs, if you like Nano, if you like Pico or whatever, go ahead. I'm not going to talk about it. I would recommend, just for your own sanity, that if you want to edit files, that you leave your terminal and you go back to using your regular Finder and whatever else. If you ever want to open up your current working directory in your Finder, at least on Mac OS, you can say open dot. Dot Remember, 2 dots means your parent directory, but 1 dot means your current directory. So open must take an argument. That is to say, it must take something to come after it. It must take a parameter to follow to say what specifically you want to open. But if you want to open the folder you're currently in using Finder, then you do open space dot, and dot will refer to your current working directory. And there we go. I've just opened up a Finder window with my home folder, right? Because that's where I was. That makes sense? Cool. And then from there, I can go ahead and open up Sublime Text, or I can do whatever I want here, and that'll just save me the hassle of having to deal with command line text editor.
So make sure I get it open and to put anything, but dot will go to the directory.
Yep.
And any file name will go to the file.
Yeah. So if I wanted to say like open, test.txt, then it would open that up in whatever your default handler is for text files. If you wanted to open up a folder not inside your terminal, you could say open, downloads, and it will open up that downloads folder. Cool. So there's that. Let's see. So you now know how to create files. You now know how to open them, at least in Mac OS. In Windows, instead of using open, you use Explorer for the same thing. At least I think you do. So there's that. And then there's something else, the same way to do it in Linux. I think it's either Nautilus if you're using GNOME. I'm not going to even talk about it. OK, so the next thing that you want to do is create folders. So if you want to create a folder, wait, what's inside foo really quick? Oh, good. Wait, what's inside it? Yeah. Oh, good. Yeah, OK, I can remove this. So I'm going to remove a folder really quick. Just don't mind me. Wait, what? Oh, I'm inside it. We'll talk about RM in a second. But if you want to create a new directory, it's mkdir. Stands for make dir, make directory. So you say make dir something. So I'm going to create a directory that I just deleted called foo. By the way, when you start looking at code, you might see the word foo in a lot of different places. I forget the term for what foo is, but it's a fake word that people use what? It's a fake word that people use when they don't actually want to think of some real word to use. It's just when they're kind of like mocking something up, writing a simple test that doesn't really need real data or something like that. I forget the name of here. 1 second. They are called.
You know what foobar comes from?
Metasyntactic variables, that's what they're called. Foobar comes from FDUB beyond all recognition. I know that, and that's like an Army thing. But yeah, so foo and bar, people kind of do that. But yeah, placeholder names in computer programming, computer related documentation. So foo just means nothing. Yeah, so make sure foo, it's going to create it. And now I can cd into foo because I've created it. Great, right? And I can cd out. Inside, now that I'm inside foo, I can say make dir bar. And then I can cd into bar. So now I'm in foobar, foo/bar, right? And if I want to go back to home, I can do cd or cd tilde or cd .. What does this mean? Yeah, basically, if you think about it, slash means folder, right? And .. means parent folder. So if you say parent folder / parent folder again, it just means go up to the parent folder and then go up to that parent folder again. So it just means go up 2 levels. So now I'm back in my home directory, right? So as you can see, there's a lot of different ways of doing the same thing in your terminal, right? Just fine. And if I want to go way back into that foobar folder at the same time, I just do foo/bar, right? Going to start with the foo directory, then slash going to go in the bar directory, and there we are. See? Does that make sense? And understand how I got 2 levels, right? Let's say that I actually don't want this bar directory anymore. Well, I can use the rm command. I can say rm bar, or can I? Can't do it because bar is a directory. Rm, which stands for remove, allows me to remove files and directories. But in order for me to remove directories specifically, I need to specify that this removal is going to be recursive. What do I mean by recursive? It means that not only do I want to remove the bar directory, but I also want to remove any other directories inside it or any other files inside it as well. So in order to be 100% sure that I mean to remove this folder and possibly anything else inside it, I do rm-r bar. So this is one of a few cases in which you're going to see a little sort of thing called, I think it's called a flag, where you can pass a specific flag into a command like rm to make it work slightly differently. This is known as an argument, where you're passing in specifically what you want to operate on, but -r, usually flags start with a dash, not always, but they usually start with a dash. They allow you to slightly change the way that the command is going to run. So by running -r, it will do a recursive remove, getting rid of the folder and everything else inside it, which is necessary for directories. So that seems to have worked. I do an ls, there's nothing here, and that seems to have worked, right? You don't have to do that for files, of course. If I want to touch bar.text and then rm bar.text, it just works fine, right? It's not bad. So yeah, that's creation of both files and folders. That's removal of them. There's also copying and moving. You can do that as well. So let's say, for example, that I want to make a thing called bar.text, and then I also want to make a carbon copy of it. Looks like this. The copy command takes 2 arguments. No flags. Well, it does take flags if you want, but in this case, it's taking 2 arguments. The first one is the input file, and the second one is the output file. Specifically, which file we're going to copy and make a duplicate of, and what we're going to call it. So now you can see that I have 2 files. They're identical. They're both blank. You know, that's cool. I think the same rule applies for if you want to copy a folder. You probably have to use the -r flag to copy it, unless I'm mistaken, but I'm probably not mistaken. Another thing you can do is move files. So you can move them to a different place. If you don't want them to be in a specific directory, you can specify the new directory you want to move the file into. So for example, if I want to move mv bar.text into the parent directory, that is to say I want to move it back into my home directory, or I wanted to say like tilde, or I wanted to try to move it into my root directory. I can do all those things, I think. So move bar.text into home, it does it. And as you can see, it's no longer here. Now, another thing you can use move for is renaming. There is no separate command for rename. Move is rename. What you can do is you can move a file to the same directory it's in with a different name, which essentially renames it, right? So if you want to rename bar2.text, you do move bar2.text to bar.text or something, right? Or let's just say something.text. And now it has been renamed. It is, in essence, been moved to the same location under a different name. Yeah?
There's a file that already exists with that name, would automatically override it, or would?
That's a really good question. Let's find that out. Touch bar.text, move bar.text, something.text. Yeah, it looks like it overrides it. That's scary. Yeah, something you should know, specifically about, well, move, but mostly about remove, rm. If you accidentally rm something, you're out of luck. That's too bad. You are 100% completely out of luck. Unless you shut off your computer right now and take it to a forensic thing and have them try to, like, you know, unerase the 1s and 0s on your drive, which is a lot harder nowadays because they're all solid-state drives. There is no trash can in terminal. I probably should have said that right off the bat. There are no takebacks. There's no way of undoing a move or definitely a remove inside your terminal. So you should be very 100% sure that you know what you're doing. Fortunately, there are a lot of folders on your machine are password protected. So if you accidentally try to do like rm/, Well, first it's going to say is a directory. So you might want to add the recursive command. It'll still say, no, you can't do it because you don't have access to it. I'm not going to tell you specifically how to remove your root directory because it will work and your computer will stop working. So be extremely careful. If you want to try it, open up a virtual machine if you know what that is. Do something in a safe place where you have administrator privileges on a thing that you don't care about. But don't do it here. I'm not even going to tell you the full command on how to remove your entire drive because why would I? So, but it's out there. Anyway, yeah, like, that's a fun prank to pull on someone. No, not really. Yeah. Okay, so,
Sorry, can you repeat the thing about when you move something into the same folder, that's the only way to rename it? Like,
yes,
So, could you repeat that?
sure. So let's say that you create a file called noisebridge.net. Whoops, dang, I misspelled it. Nosebridge.net. So I have to rename it. I just do move nosebridge.net, noisebridge.net. Oh, something I should, oh, sorry, .text, .net, .text. So this is going to rename this to that. And if that file already exists, it's probably going to clobber it with this. So make sure you're not moving into a target where something already exists. By the way, if this refers to an existing folder other than a file you want to rename it to, it will simply move that file into that folder. So move can, depending on whether what this second parameter is an existing directory or not, either move a file into that directory or move a file to become this new file that might or might not exist.
If there's no path in the second part, it's just going to rename it.
Well, here's the weird part. Let's make a folder called noisebridge.txt. That sounds weird. Why would you create a folder with an extension? You can. There's really kind of nothing stopping you from doing that. As you can see here, this is now blue in my thing that's highlighting that as a folder, right? And I can go into it. I can say cd noisebridge.txt. Now I'm inside /food/noisebridge.txt. So if I run that command again to move nosebridge into noisebridge.txt, it's not going to rename it. It's simply going to move it into this noisebridge.txt folder. See? So move does two different things depending on whether the target directory exists. By the way, you might have noticed that I was typing quickly in some cases, so quickly in fact that it almost looked as if the terminal was completing it for me. That is exactly what was happening. If you have a very long file name and you don't want to type in the entire thing, you can say cd space n tab, and it will fill in the rest of it for you. So tab is your friend. Tab fills in whatever's left. If there happens to be some sort of, conflict. Oh, you can only. Okay, hold on a second. Oh yeah. So let's make another file called. Let's make another directory called makedir noisebridge2.txt or whatever, right? And it doesn't even have to be .text, it's just whatever. But now if I try to say rm and tab, it's going to stop right there and make me fill in the other two things, make me fill in the rest because there's ambiguity. There are two different files that I could be referring to. If I press tab a few more times, it'll give me the options that I can choose between. So, I can't go any further because I need to choose between one or the other. So if I type 2 here, then it knows which one I'm talking about, right? So tab is very helpful to a certain extent, at which point you need to continue to type. So that speeds you up significantly, pressing tab whenever you're referring to an existing file within your folder or somewhere else that you're referring to. Yeah?
So we know we can do ls and then asterisk dot whatever the file type, it'll list all of those file types. And
Yeah.
then we have these folders.
So you're looking to list out all folders in a directory?
All like subfolders in your parent directory.
I can probably do a recursive list. Recursively list subdirectories encountered. So that would be escape. Sorry. So I guess you could do something like ls-r foo, and then it'll list out recursively everything that's inside that and what's inside the subdirectories. Yeah. By the way, what I just did there was I did man ls. Man stands for manual. Man allows you to learn how to use a specific command, but it's highly technical. This is like some spec level stuff where like they're using very precise, often scientific terms to tell you exactly how to use a specific piece of software, and so you can get confused by it very frequently. I'd say a better way to find out how to use a certain command is to Google it. You had a question?
Yes, it auto catches the first letter.
Yeah.
Is that what it does?
It fills in the rest of the letters if it knows what your file you're talking about. And so based on, if you're in a folder where only one file starts with an N, and you type N and then tab, it's going to fill the rest of the file name in. Make sense?
How do you get out of the manual?
Oh yeah, you have to type Q and then it takes you out of it. Q. Very not helpful, not user friendly. But that's how you get out of there.
Q and then what?
Q, that's it. Just the letter Q gets you out of the manual. Yeah.
You listed recursive foo and it comes out. Or the list capital R, dash capital R.
Yeah.
How did I miss that? What was the dash R?
Dash R means recursively list. This is another example of one of those flags. I talked about like flags, like a lowercase dash r with remove, that recursively removes everything inside a folder and everything inside it. Uppercase dash r, I'm not really sure why it's uppercase versus lowercase, but in this case it's uppercase. This lists recursively what's inside a folder and what's inside all of its subfolders. Yeah. So if I did that from like my root directory, that would be really long and just keep going forever. Yeah, it would be everything. In fact, it would probably go for so long that I would probably want to stop it at some point. So I would probably have to halt it from happening. We'll be talking later on in the class about running servers from our command line. But if you ever find that your command line is frozen, like you don't get another prompt, like for example, some piece of software or some application that you're running on your command line has kind of taken over, and not in a malicious way, but it's just like continuously running and not letting you type another command, you can always type in control, not command, but control C, and that will bring you back to your command line. That'll close whatever files are running, whatever applications are running on your command line, and bring you back to the command line, so you can type in more stuff. So that's one way of quitting stuff. So I think that's all I really want to talk about in terms of the command line. We pretty much know how to manipulate files pretty much the same way we do it within Finder. We can move things, we can copy things, we can remove them, we can create new files and folders, we can navigate throughout our file system, we can find out where we are, list out what's inside our directories. All that stuff is pretty helpful. So those are really just the basics on how to be able to go through your computer and your command line. Yeah?
Can you go through make directory one more time?
The what?
Make directory one more
Oh,
time.
sure, yeah. I mean, to make a directory, you can just say make dir and then the name of the directory.
I wrote it down.
Yeah, oh, mkdir, yeah.
Thank you.
Ta-da. By the way, there are some file systems where you can have spaces in the name, but if you try to do something like make dir the name of my directory, it's not going to do what you want. There's going to be directory my name of the, that's alphabetized. I just made five different directories. So if you want to have something with spaces in it, you have to surround it with quotation marks. So now there's an actual thing called the name of my directory. And if I want to cd into it, I should do the, probably should have done that with quotation marks. The name, see, and then I can press tab to delete it and everything.
I just
So-
learned a weird way with slashes.
Yeah, you can use a backslash to make it so the next space is interpreted as part of the file name. but I think it's easier just to use quotation marks. Yep. So spaces are fine, but they're sometimes a little confusing. Yeah.
What if there's a permission denied response?
Where are you right now? If you do a
I don't know,
PW,
I don't know where I am.
no, do a PW. If you do type in PWD, you'll find out where you are. And if you're not inside users / your username,
Oh,
then
that's
you,
not-
yeah, you're probably doing it within your root directory or something where you should not be messing around. It's not going to break anything. Like I said, it's preventing you from doing much harm. But I'd recommend doing stuff in your home folder because that's kind of the place to just play around and do whatever you want. Of course, removing everything from your home folder is a bad idea because that's probably where you put all your documents. That's where your desktop lives. That's where other stuff is. So don't do that. That's a bad idea. But it's up to you. Yeah. Cool. I think that's that. I think that we can now start talking about what Git is, unless there are any other questions. Well, cool. At least now you can impress your friends. If you make your screen look like this and you start doing a whole bunch of cool commands, people will think you're hacking the planet. That's what we're here to do. Okay. So let's talk about Git. Git is a source control management system, version control management system. What it allows you to do is keep track of your code. What I mean by that is that as you're working on a piece of software, you are going to be making changes to it. You're going to be making a lot of changes to it. In fact, you're going to be making so many changes to it that at some point you're going to want to set little milestones where you can say, this is a good stopping point. I'm ready to say, put a stake in the ground and say, this is a good sort of like little ending of a feature that I've decided to add to my piece of software, or a little bug fix that I've gone ahead and completed. You can start to think of your code in basically like a whole bunch of different sorts of incremental steps toward whatever goal you're trying to reach, right? And Git helps you out with that because you can go ahead and use it to say that you are reaching a place where you can commit your changes. Committing your changes essentially means everything that I've written so far I'm okay with and I'm ready to continue. The cool thing about that is that with every commit that you make, you have the ability to roll back to a previous version of your project. So if you want to look back 5 years ago at some open source project that's been around for a very long time and see what it was like, you can do that. You can check out that code from 5 years ago, see what ridiculous things they did back then, and then you can fast forward to the present day and see what it's like now. Another cool thing about Git is that not only can you make commits, but other people can make them too. What this cute little illustration is trying to show you is that this piece of code can be split out into 2 different versions of code, where 2 people, Mr. Yellow and Mr. Red, can work on these things, and then they can essentially merge all those commits back into a single master piece when they're all done with it. So Git allows you to distribute your work among different sorts of parallel versions of your code, where everybody, and also you're able to host it somewhere where everybody can download it and make changes to it and contribute those changes back to the source, to the origin, to the upstream. So this is really helpful stuff. It makes it so like if you've made a mistake, you can always undo it. If you lose all your stuff, if your laptop falls in the lake, you can download it from wherever you're storing your stuff, which is hopefully off of your computer. If you want your friends to help out with it, they can also download a version. You can give them privileges to make changes to it and contribute those changes back to you. So Git is the system that makes that all work. So you might notice, though, that there's no place to sign up for Git. There's no place to create a new project on Git. There's none of that. That's because Git is not a service. It is an application on your computer. It is something that you download to be able to create these repositories, is what they're called, Whereas you've probably heard of GitHub, especially since I told you all to sign up for it. GitHub is one of many places where you can upload a version of your Git repository for everyone else to see. So I don't want you to get it twisted. Git and GitHub are two different things. GitHub has the word Git in it. That does not necessarily mean that the people behind GitHub have anything to do with Git specifically. That said, you go down here and you'll probably see that this page right here is hosted on GitHub, but that doesn't necessarily mean that Git is owned by the company GitHub. In fact, it's not. It's an open source project that has some maintainers, but can be contributed to by a lot of different people. Yeah?
Does Git have any competition, or is it a monopoly?
Good question. Git is one of many different version control systems. There are other ones called Mercurial. There's Subversion. There's CVS. I forget what that stands for. There's SourceSafe. There are a whole bunch of different ones out there. Git is by far the most popular one nowadays. Subversion used to be the most popular one, I would say, 6 or 7 years ago. They're slightly different in how workflow happens, in like how you're able to distribute your stuff to different people, how you're able to branch out your code into different sorts of parallel versions, and how that all works. But it all really comes down to being able to create different versions of your stuff so you can see little incremental milestones. And every version control system is all about that. GitHub also has competition. GitHub is just one business that runs a website, GitHub, that allows you to store your repositories on. But just because you're storing it there doesn't mean they have full control over it or that you're giving it to them. You can also host your stuff in a bunch of different places. Another company is Atlassian, and they run a website called Bitbucket. Bitbucket is another one. And then there's also a piece of software called GitLab that allows you to host your own Git repositories on your own server. So there are a whole bunch of different places out there where you can manage your Git projects or your version control projects. And GitHub is just probably the most popular one. GitHub is so popular, in fact, that there's really kind of a community behind it. Like if I go to my own account here, github.com/jeffreyw, you can see a list of different repositories that I either own or that I've worked on or that I've contributed to. You can also see a little description about me. There's different sorts of contributions I've done in the past year, organizations I'm a part of, and some people even hire based on what's on your GitHub repository. So if you are looking to get into this line of work, just coding in general, I would say having a public GitHub profile is very important because people can see what you're up to. It's worth noting here that I think I'm logged in as myself. So if I opened up an incognito porn window and took a look at this, my contributions would be a little different. So you see how, based on this and this, my contributions are a little slimmer. This is 671, the other one said over 1,000. That's because when I'm logged out, you see a little bit less about me. Because with GitHub, the way that they make money is that you can host private repositories. So people from your company or from your organization can work together on something that is closed source. Closed source and open source. The difference basically means that you're just not letting people out in the open see your code. So by default, when you create a Git repository using GitHub or you host it on GitHub, the initial option is to make it public so everybody can see it. But a lot of businesses conduct their business using GitHub, and they don't want everybody to see all their proprietary information. So they pay a certain, amount of money per head and per repository for privacy, so no one else can see it. But if you're willing to keep your stuff open, and it's good for you because people can see the kind of coder that you are, then it's completely free. So that's a pretty cool service that GitHub's providing. Yeah, but as you can see, I look a little less productive than I do on my private one because I've done a lot of private contributions as well. Hi, you're asking me how to print the date automatically. I think that what you were talking about is this little thing right here on the right where it's showing the time. I've got a custom prompt. it's a little bit beyond the scope of this class, but there are ways where you can customize your environment within your terminal, different ways of changing, what happens when you run certain commands, or how your command line specifically looks. And I've gone ahead, and every time that my command line starts up, it runs a few additional commands to sort of put my thing together, make a nice big blue bar and a green bar and a yellow bar with the current time, and also the pizza emoji, so that's cool stuff. But it's a little bit beyond the scope. But if you want to look into it, you can learn how to create a custom prompt. Just Google up, custom terminal or custom command prompt to find out how to do that. All right. Anyway, I assume that you've signed up for GitHub. So, but before we really get into GitHub, let's just go ahead and create a new project using Git, or let's create a new project and manage it using Git. So I'm going to navigate into my usual place that I do my stuff. So you can feel free to do this outside of the terminal. If it's a lot faster for you to use the Finder to just make a folder wherever you want, you can just do that. You can open up your Explorer or whatever. Go into here, go into whatever you call it. Create a new thing for today's class. Call it whatever you want. Class 3. This really doesn't matter. But I want you to navigate to that directory in your command line. So make sure you know how to cd into a specific directory, or cd into a nested directory by doing this/this/this until you can find it. So I'll give you a minute just to do that while I rehydrate. Yeah, what's up?
So, I have a question about Git. So, for all of the contributors who make a copy of that person to upstream,
Yeah.
is the person who maintains that upstream one is the one who approves everything?
Yes,
So
generally.
how is that?
Yeah, management can be complicated. So your question was about how a Git like an open source project gets managed. Let me see here. So my company, Lab0, has a public repository on guides. We put out some public guides on our best practices on how we write certain kinds of code or whatever. And all of these are open source. And if you wanted to change our guides, if you had some recommendations on how we could better work for some reason, then you can go ahead and clone this repository. You can make changes to it, and then you could create a new pull request where you choose your version and say, hey guys, I want to make some changes. What do you think? And they can go ahead and approve it and press a button, which automatically merges all your changes into this version. So for every project on GitHub, you can designate a series of owners, or team members who are able to approve commits or able to approve pull requests and merge them in there. So that's kind of how it generally works. There are really, really big open source things like the Linux kernel, owned by Linus Torvalds, whatever. This guy is a crazy open source contributor, and he's been doing open source contribution since the 80s, 70s, a very long time. And of course, he created Linux, which is a very, very important, popular operating system, right? And you can navigate the entire source of it on GitHub. But as you can see, there are a lot of pull requests. There are people who submit pull requests here saying, "Hey, I feel like you should be able to change some stuff here. Looks like this isn't formatted well, so I'd like to change it from this to that." And then someone would comment saying, "Sorry, we don't accept GitHub PR, so I'll have to send a patch via email." So this isn't a very good example. Let me show you something like Rails. Rails is a very popular application framework for websites. I'll be talking about Rails at the very end of this class, since it's more of a back-end web development thing than front-end. But you can navigate the entire code base, and you can also see pull requests. Say like, update the guide, and this is what it is, and someone says, it looks like, let's keep this information, let's not get rid of it. Thanks, good find. Can you make changes? And when we make changes, whoever runs this thing will be able to press a button that shows up right here that says merge. And then all of that code that they've contributed will be merged into this repository. So that's kind of how the general workflow works. It's pretty cool. Yeah, no problem. But before we can contribute anything, we need to create our own repository. Or, well, you don't need to create your own repository necessarily to contribute to someone else's work, but let's create our own repository so we can do that. Eventually, I'm going to create one that other people can contribute to. That'll be cool. So I'm going to create a new folder called Shakespeare 10. It's okay if you can't spell Shakespeare. It's kind of hard. There's an E in there, and there, and there. Why 10? Because this is series 10, and I've made a few of these folders already. So Shakespeare 10. I'm going to go into Shakespeare 10. And if I have Git installed, remember, if you're using Windows, you should be using Git bash at this point, hopefully, because all the other commands that we ran earlier probably won't work if you're not using them. I'm going to run git init, which is short for initialize. And it says initialize empty Git repository and blah, 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 dot git.
Yeah.
What Git just did was created a hidden folder in this file, in this directory called .git. If I do an ls, I can't see it. The general idea is that files or folders that start with dot are by default hidden. Means that they're kind of background stuff you don't need to deal with, stuff you don't need to see as a user. So they're just not there for you to see. If you do want to see them though, you can say ls-a, and it lists out everything. -a means all, essentially. So this hidden folder is here. But you don't have to worry about that. What's cool now is that now that we've initialized this folder as a Git repository, we can run a whole bunch of different commands once we start doing our work to commit our incremental changes that we make. So here's an example of how I'd like to start. First thing that I'm going to do is create a new file. I'm going to call it romeo.txt. Cool. So now that I've created romeo.txt, I want to open romeo.txt. If this doesn't work for you, if this doesn't open up in your text editor of choice, then you can just say open dot and open up this folder here, and then open this up however you want. Use whatever text editor you want. We're not writing code today. We're writing Shakespeare. So, yeah. So now we're outside of our terminal for a while, and we're going to start writing some Shakespeare. In fair Verona, where we lay our scene. Oh, I died. Cool. So it needs some work, but here's Romeo and Juliet. Romeo dies, spoiler alert. Cool. So good. We just wrote some stuff. It's not code, but that's okay. Now, I'd like to go back to my terminal. And I want to do a git status. So git is keeping track of what's happening in my folder. Hopefully, you should see romeo.txt in red. If you don't see that there, then either you created romeo.txt in the wrong folder, or you forgot to do a git init in the same folder where you created romeo.txt. So make sure that when you're doing all your work, you're doing it in this folder, or else you're not going to see any changes, right? Yeah?
I see an extra thing.
What do you see?
.ds_store. Is that the
Ah.
same thing?
If anyone sees .ds_store, that is macOS's way of generating thumbnails for files in your computer, files in your folder. What I mean by thumbnails are little itty-bitty versions of images, so it can easily display them within your Finder. You know, like for example, this picture of my cat. The reason that there's this little picture of my cat there, even though the picture itself is very large, is because there was an automatically generated thumbnail file to store those sorts of things to make them very easy to. So in case you ever see DS store, ignore it. It shouldn't be checked in. It shouldn't be dealt with. It's just gonna sit there and you don't worry about it. Yeah.
I see a romeo.txt and then the wavy sign after, so I have romeo.txt.
Oh, what text editor are you using?
Linux.
Ah, yes. Yeah, so what Linux is doing is it's creating a swap file. It's essentially a place on your disk where it can store some changes while you're working on it. Essentially, in case your editor crashes, it's got a backup version of it. So that's what that little tilde thing at the end is. Don't worry about that. Just try to ignore it. And don't make any changes to it, because your text editor is going to take care of that for you. Yeah?
So I thought you said that git init made it like an invisible file. Why do you need it in order to see that it's created to romeo.txt?
Well, whenever you run the Git folder, the first thing it's going to do is look for a Git folder. When you run that git init command, the first thing it's going to do is look for that Git folder. Because inside that Git folder are some configuration things about what your project is called, how old it is, how many commits there are, all the past commits that have taken place, and everything outside of that folder, outside that hidden .git folder, are really just going to be regular files. The cool thing about it is that because all those older versions are stored inside that hidden folder, any command that you run with Git, you can go ahead and completely change your entire folder structure to reflect some sort of older version. So that's where all that data is stored, that it can apply to the rest of your thing. So that's why it's there. That's why you don't have to worry about it. That's why it's kind of hidden. And that's why you should feel free to make any other files you want inside here, and just make sure that in the background you've got this .git thing. And you can tell that you do just by running a git status, because it'll tell you whether you are inside a thing or not. Like if I go up one directory, cd .. and I do git status. Oh, actually, I am inside. I personally am inside another Git repository because I store all of my code. I store all of my code for my class in a Git repository, so I can easily upload it at the end of class. So you're not going to see this. You're going to probably see something like not a Git repository, right? Anyway. One more thing that you might find useful, I only found about this recently, is that if you go to a certain place that you didn't need to go to, you can say cd dash and it'll take you right back to where you were. So if you cd tilde and you meant to go, you didn't do that, or cd slash, just do cd dash, it'll bring you to the previous place. So that's kind of cool. Anyway, git status. Cool. So let's read out what's going on here. The first line, on branch master. We'll skip over that for a second. We'll talk about branching a little bit. Next thing, initial commit. Remember how I was talking about how how a Git project is just a series of commits, little incremental changes one after another. We have not decided to commit any code just yet. We haven't decided to create a milestone or create a version at which we're okay with what we have, and then we continue on from there. So that's why we're on our initial commit, because nothing's been committed yet. Next thing is untracked files. An untracked file is a file that shows up somewhere inside your Git project, not necessarily inside this folder, but within some subfolder or something like that Git currently doesn't know anything about. It realizes that it's there, it recognizes it, says there it is, but it's not tracking any changes to it. If you make additional changes to this thing after your first commit and you keep making changes, and you try to give someone else the repository, you try to download it somewhere else later, you're not going to see any of those files that Git isn't tracking. So you need to tell Git explicitly to track stuff inside your folder, because there are certain cases in which certain projects you're working on, you have some temporary files or temporary folders or some scrap stuff that you're working on that you don't want to commit. So untracking it basically makes it so Git will not automatically notice that you've made any changes to your files, which is what Git can do, which is kind of cool. So if we want to start tracking it, we do what it says here. Use git add so-and-so to include what will be committed. So let's do git add romeo.txt. Now if I do a git status again, then it says we're still on our initial commit, and there's a change to be committed. Cool. So let's commit it. Let's say we're good with what we have, and now we're ready to continue forward. And this is what it looks like. Git commit -m add Romeo and Juliet. So when I run this command, it's going to sort of increment my Git repository by a version. I'm now going to be on version something, which is like, it contains all the stuff that I've done so far, and now I'm going to be starting kind of from a fresh slate. Any other additional changes that I make, Git is just going to compare the changes I make to this point right here, right? So this command, git commit, has a -m flag on it. This -m flag needs to be followed by something in English. Something that I usually put inside quotes because it's going to be multiple words. And it's just going to be an English message that I write that is going to say exactly what I'm doing in this commit. So it's just, this is for your sake. This is so you can go back and take a look at all of your commits in one big list and see specifically what you did, what changes you made. So here are some bad commits. This is bad. Add new file. That doesn't tell you anything about what you did in this commit. Certainly you added a file, but you're doing that all the time. This probably isn't helpful either, right? Add a play, because there are going to be a lot of plays, right? So when you say add Romeo and Juliet, there's no mistaking what you're doing there. That doesn't mean that Romeo and Juliet is done. Obviously, we didn't write the whole thing, right? We will by the end, just sit tight, we'll write the whole thing, sure. But this says exactly what you've done. So make sure it's descriptive. Make sure that what you write is something that you'll be able to go back 5, 10, how old is Shakespeare? 400 years down the road, and look at and go like, oh yeah, I did that, right? Great. So this gave you a little thing saying blah 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 blah. Add Romeo and Juliet. One file changed with 9 insertions. Create mode something Romeo.txt. There's a lot more information that is necessary here, but let me show you specifically what's going on. We are now at version 230D249 of this repository. Why isn't it just version 1? Why not like version 1, version 2, version 3? The reason that versions have these really long random numbers is because, think about it this way. If you've got some sort of distributed project that 100 people are working on, and people are making changes to it day in and day out, who's to say who's made version 2? Who's to say who's made version 3, right? I mean, especially since this is all distributed and everybody has their own version of the project on their own computer, these computers aren't talking to each other and saying, hey, computer so-and-so, have you created version 3 yet? So no, there's no way of doing that. So every time you create a commit, there's another really long thing. This is actually just a very short nickname version of it. It's actually a very long string. Here we go. This is the full string that tells you what version you just created. And it's okay that it's not sequential, that it doesn't really make any sense. It's not something you're supposed to memorize. This is showing this is version so-and-so of this repository. So one file changed, 9 insertions. An insertion is a new line in a file. As you can see here, there are 9 lines in this file. And I created all of them. So those are 9 insertions, right? So that's that. And as you can see here, when I run git log, it lists out all the commits for this project. So on July 25th, 9:07, me, Jeffrey, added Romeo and Juliet. By the way, if you ran git commit -m so-and-so, it might have asked you to enter your name and your email. If it did, that's great. If it didn't, then it might have simply inferred it by something else. I'm not sure. But hopefully that'll work for you guys, right? Cool. Yeah, so there's that. Great. So let me make another commit. In favor of running our layer scene, some dude, I bite my thumb at you, dude. Juliet, I, me. Hey, a girl. Okay. Okay, so we made some changes. I made sure to save it, of course. I'm going to go back here and do another git status. Okay. So git notices that Romeo.txt has been modified, but it's in red, which means that if I want to make a second commit saying I'm ready to go to version whatever of my file, that everything I've done so far I'm okay with, if I do a git commit now, nothing's going to happen. It says no changes added to commit. I need to be explicit about which files I want to stage for the next commit. Because there my workspace might be in a situation where there are some changes I've made, but I'm not sure about, but some changes I've made to certain files that I'm definitely sure about. So if I want to stage those files for the next thing, it's the same as telling Git to track them in the first place, which is git add romeo.txt. Same thing as before. And now it says changes to be committed. Romeo.txt has been modified. Right? And now I can do git commit -m introducing Juliet. Cool. Now that I've added this commit, I can do a git log and see 2 commits, right? Adding Romeo and Juliet, introducing Juliet, right? I just committed a faux pas and I have 2 different verb tenses here or something, add and introducing. I usually like to make it the present, like introduce or add or whatever, but whatever. Anyway. Yeah, so I have 2 commits in my thing so far. Great. I'm going to stop making commits for a second, and I am going to allow everybody in the world to see my stuff. Way before prime time, you know, but whatever. They're going to see my work on Shakespeare as I do it, which is going to be cool. So let's do that. First thing we have to do is go to a place such as GitHub. And now that I'm here, I can go ahead and create a new repository. Click that green button to create a new repository. I'm going to create a repository called Shakespeare 10. And description, the complete works of William Shakespeare, Series 10. So you got a few options here. You can say that you want it public, or you can pay them money. See, upgrade my account, pay with credit card, blah, 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 blah. Or you can make it public, meaning it's open to the world, no strings attached, it's free. Also, there's a question of initialize this repository with a README. A README file is something that you should usually create when you create a repository. A README file, which is really just a text file called README, or a markdown file if you know what that is, allows you to simply explain to people who are coming to your repository what it's all about, helping them set it up, helping them contribute to it, helping them understand specifically what it is. But we've already locally initialized our repository. Remember we did a git init? So we don't want to do that here. Instead, we want to simply push up our existing repository that we created locally instead of initializing it here. So don't check this. Also, don't add any of these things. Just press create repository. Okay. So, quick setup. We haven't done this thing before, so you can't do that. Create a new repository on the command line. We already did. You should notice that a lot of this is very similar. Git init, git add, git commit. But these are the two lines we want. Git remote add origin, git push -u origin master. Okay, so let's talk about what all that means. Git, again, is a distributed version control system, meaning that wherever you're working on your stuff, you have the ability to push the repository and all the commits that you've made somewhere else. And that somewhere else is referred to as an upstream. An upstream, because you can think of it as, you know, your code is flowing upstream, but you can always pull stuff down from it, the big hungry bear, and you know, just get the latest stuff. And everybody is pushing upstream. So the command git remote allows you to inform your local repository of an upstream repository that you can push your changes to. So git remote add, the name of the repository we're going to call it is origin. Origin is a very common name that people use for the single repository to push to. There are some projects that have multiple origins, which is really interesting. Like some people will be making changes in 2 different places. And so it's your responsibility to pull down and merge changes from 2 different locations. Like, for example, the Linux kernel. A lot of people are sending pull requests saying, hey, change this, change this. But despite it being kind of an upstream where code is pushed, it's not a place where Linus or his team at all make changes. So you have to send them somewhere else. So there must be some other upstream somewhere else for Linux specifically. But anyway, here we go. These 2 commands do it. So specifically, we point out the URL of the place where we're going to upload our stuff, and then we go ahead and push it. Pushing is pretty much the same as uploading. It's just saying like, hey, repository, do it. Git push -u means we're going to specify which upstream we're talking about, origin. Origin, again, is going to be the name of this GitHub repository. Finally, master is going to be the name of the specific branch we want to push. I still haven't talked about branches. We'll talk about that in a second. Yes?
When we create the repository, we name the text here, it has to correspond with the existing repository we created on our folder.
You mean by the name?
Yeah, when we first created on, or if you know, is there going to be a file where we're going to just create it?
The name does not matter locally. The name of your folder can be whatever you want it to be. The upstream that you created, that's fine. I mean, inside your folder, it's going to be referred to as origin, not as Shakespeare10.git or anything. So no, your local folder doesn't have to have the same name as your upstream. That's just a common thing that most people do. Yeah. But if you can't do it for some reason, that's okay. So just go ahead and copy this and paste it into your command line. Pasting in Mac OS is very easy. You just do a Command V. But on Windows, you might have to right-click on the title bar and then choose paste from there or something. It's really weird. So yeah. Yes? Oh, that.
Yeah.
Ah, okay. Yeah, so you probably did a commit without the -m thing, right?
No, I tried to follow the directions and I think amend something.
Ooh. Okay. So
How do I get up?
yeah. So what you've done right now is that there are cases where if you commit, I'm not trying to make an example of this or anything, but this will happen. There are cases where you'll commit and you might forget to add a message to your commit. Try not to do that. You should always add a message to your commit. But if you forget, or if for some reason you need to make additional changes to your commit message or something, you might find yourself in a text editor inside your terminal. That text editor will look really strange. It'll have a lot of like tildes going down the screen, just tilde, 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 something like that. It'll look really strange. To get out of that, the one thing you need to know about Vim, or VI, which is the text editor that's there, is how to leave Vim, is how to get out of it. And that is :WQ, enter. You type that, you type :WQ, if you ever find yourself in something that looks like Vim, that looks like, let me try to look for a very simple example, but of course simplicity is not the name of the game with Vim, so great. None of these are what they actually look like. Whatever. Looks like a text editor. Looks like something that doesn't look like a command line. Then you just do :WQ to get out of it. I'm sorry, :Q, or :Q bang. Sorry. W means write, so that means you're going to save whatever you're making changes to, which you might not want to do. Q means quit, and if you can't quit, then you might have to do a :Q exclamation point. This is why I hate Vim, to get out of it. So
None of these work.
Close your terminal and reopen it. Yeah. Okay, so, right. Okay, so back where we were, I was going to add a remote. Oops, I'm not in the right directory. Let's try that again. Add a remote. Not a Git remote. I'm stuck. What? Sorry. CD, FWD, Series 10, Class 3, Shakespeare 10. There we go. Let's try that again. Git remote, add origin, so and so. Great. No complaints. That worked for me. Next thing is git push -u origin master. Now, at this point, it'll probably ask you to enter in your username and password for GitHub. Or it might say something about an SSH key. You might want to skip that step if possible. If you have the latest version of Git installed, then there should be an easy way to just enter your username and password and just log right in and be able to push your stuff directly to GitHub without any fuss. Did that work for everyone when they did that? Because you should see something like this. Branch master set up to track remote branch master from origin. So that means you have a local checkout, a local repository with something called master, and GitHub now has something called master, and those two are related to each other. You push up changes, they're going to go there, and the upstream is called origin. That's what you just called GitHub's upstream. So there you go. Went ahead and pushed it, uploaded it. It took 672 bytes. That's not a lot, and you're all done. Okay, so let's reload this. And now, it should not look like an introduction thing. It should look like Romeo.txt. And you take a look at it, and there's the entire thing. You press the history button up here in the upper right, and you see the two changes I've made. Check it out, the two Git commits. Take a look at one of them, like introducing Juliet, and you see what it was before and what it is now. My second commit has 1 deletion and 5 additions. Why is this considered an addition, a deletion? Because there's no such thing as a modification when it comes to commits. Either you've deleted the line and added a new one, or you just deleted it, or you've added a new line, right? So it's just deletions and additions. That's all that it is. That's all these changes are. But it's pretty cool that you can see this. It's called a diff, a differentiation of the old stuff and the new stuff. Cool. So there's that. And also a comment saying, good. And now, now I'm commenting on this commit. This is something that's GitHub specific. This is just for collaboration purposes. This is so I can go back at someone else's commit and saying, why did you do this? What happened here? And I can get some explanation. When you're making a pull request, which is essentially taking a look at something that looks a lot like this diff from what it is now and what they want to change it to, being able to add comments, line notes on specific lines and saying like, hey, what was this all about? Why'd you do this? Hey, you misspelled this or renamed this or whatever else. You know, this is a great place for collaboration. Okay, so there's that. That's your GitHub repository. Okay, so that's great. I wrote Romeo and Juliet. Now, although I'm not necessarily done writing Romeo and Juliet, I think I'd like to take a break and write some Hamlet. Okay, so I'm going to multitask. I'm going to write 2 plays at once. But I don't necessarily want to get all my changes on Romeo and Juliet intertwined with all my changes with Hamlet. I mean, I definitely don't want to get into the circumstance where a single commit has both changes to Romeo and Juliet and Hamlet at the same time. Why? Just because it's really hard to kind of like separate those things apart. If for some reason I wanted to revert a commit, just roll back or undo something later on, which is possible, then it would be really hard to do it if it was happening in multiple places at the same time, right? You wouldn't want to undo stuff that has nothing to do with a specific change. So that's why you want to keep your commits very small, incremental, you know, encapsulated. Do them as much as you want to do them. You know, just and keep them focused on a specific change. That change might span multiple files. That's completely fine. But it should be in the it should be with the goal of keeping it all, you know, like, you know, meaning the same thing, right? Accomplishing the same goal. So I've got a different goal. I'm going to do Hamlet. So the best way for me to make sure that all my changes are separate from Romeo and Juliet is to create a branch. A branch, you know, it's pretty much what it sounds like. It's basically, if you can think of it this way, I'm on the master branch right now. And this master branch is basically growing with every commit that I make. Think of it like a tree. There's a single branch just going upward. Every commit means another little notch in that tree, right? But I can branch off at any time and start making changes myself. And changes on that branch will not affect this main branch, right? They're 2 different things. But unlike a tree, at some point, or unless it's a really weird tree, you can take stuff that you've branched and basically take all those commits from that branch and merge them in to your main branch. So master is usually the name of your main branch. And I'm going to create a new one with this command. Pip checkout -b Hamlet. This basically means I'm going to switch to a different branch. I'm going to check out a different branch. And -b means create a branch, if it doesn't exist, called Hamlet. Switched to new branch, Hamlet. Great. My terminal even shows me what branch I'm on. It's pretty sweet. If I don't know which branch I'm on, I can just do git status, and it'll tell me that I'm on branch Hamlet. No changes, working directory clean. That means I haven't made any changes since the last commit. Is Romeo and Juliet in this thing here? Like, it is, right? That is because I branched at the point where I had already made those 2 commits, which is fine. It's just going to sit there dormant. Hopefully, I'm not going to make any changes to it. So in the meantime, within my Hamlet branch, I'm going to go ahead and create a new file. All right, so let's go ahead and edit Hamlet. Cool, that's all I remember of Hamlet. All right, so made these changes. I can go back to my command line and see that there's a new untracked file. So if I want to add that file, I can say git add Hamlet, and then I can go ahead and commit. Cool. All right. Let's make another change for the heck of it. All right, just make another commit. Why not? What's that called? A soliloquy or something? So if I'm already tracking the file, which I am, this is a tracked file, but it's not a staged file, meaning that if I commit, it's not going to become part of it unless I specify that. If I'm tired of having to stage every file every single time that I do a new commit, there's a shortcut. So if it's untracked, you need to track it. But once it's tracked, which you only have to do once per file, you don't want to have to like manually stage every single one for commit. You're like okay with how your entire working directory is, then you can just do this. Notice the A here. Git commit -a is essentially going to do an add on everything that is currently being tracked. So if you make any changes to anything being tracked, it'll just automatically stage them for this commit. And then M is your message, right? Git commit.am soliloquy time. So this is so you don't have to do a git add on every single file you change. But again, remember, it'll only work on files that have already been tracked, so you do need to run git add on them the first time. All right, so I've just made 2 more commits. If I do a push, I think I'm going to get a little error message saying the current branch Hamlet has no upstream branch. So that's worth knowing. Every branch on your repository can have a different upstream. You know, remember, when I say upstream, I'm talking about GitHub, right? And currently master is tracking the master branch on GitHub, known as origin. But Hamlet is nowhere. So if I do want to set Hamlet to be able to push it somewhere and set origin as the upstream, GitHub, then I can say git push set origin set upstream origin Hamlet. And that command's right there, so I can copy and paste it. And it's going to do it. Great. Okay. Everyone all good? Everyone pushed?
So setting the upstream creates a new branch in the remote repository?
Yeah. Yeah, so basically by pushing, and if the upstream doesn't have that branch, then it'll create it as part of this push here. So yeah. All right, so it's up there.
Not as 2 origins.
Every branch has its own list of upstreams, and GitHub for both branches is referred to as origin locally. The terms upstream and the name origin and remote branches and everything. There's a lot of terminology there. Most of that stuff I don't really care about. All I really care about is like, can I upload my stuff to GitHub?
Is it possible to have an origin that's another branch?
It is possible to have. So an origin is simply the name that we gave GitHub. We can call it whatever we want. Upstreams, on the other hand, are the concept of your local Git repository or your local Git checkout or instance or whatever, being able to push stuff to a specific place known as an upstream. Origin is the name we're giving to the GitHub upstream. So now both the Hamlet branch and the master branch are able to push to their respective branches on GitHub.
Okay.
So Now, if we go here and rename, and actually we don't even have to reload. You recently pushed branches. Check it out. Now there's a branch called Hamlet. So I can switch over to it, and now there's Hamlet and Romeo. If I want to switch between branches, I can just pull down this little drop down here and switch between Hamlet or Master. So as you can see, Master doesn't have Romeo, and Hamlet does. You take a look at it. Here's the latest version. Here's the history. I added the soliloquy. Right? Cool. That's all well and good, but chances are somebody taking a look at my repository isn't going to want to navigate through all my branches to see all the changes I've made. Chances are they want to take a look at master, because master is supposed to be kind of like the master version of, you know, what the repository is. So I think I'm at the point where I'm happy with merging my changes on Hamlet into master. So I can do two different things. One is I can do it graphically via GitHub. It's very easy. I can compare and pull request. So I can see the changes, and it looks like Hamlet.txt has these additions. There's no other commit comments or anything like that. Here are the two commits I've made, and I can go ahead and create a pull request. Pull requests are specific to GitHub, or specific to simply version control management services like GitHub, where you can send a request for the owner of the project to merge in that stuff. Of course, I am the owner of this thing, so that's kind of silly, right? But there is a way to be able to pull down this version right here and make changes, and then go ahead and create a pull request with those changes. But I'll talk about that in a second. So I can go ahead and do this. I can open up and press create a pull request, and when I do that, there will be a screen where I can, you know, make my final decision about whether to merge it in and press the merge button. And GitHub will do all the dirty work for me. But we're not here to not do dirty work, so let's do our own merge without GitHub. What I want to do from the terminal is merge all of the commits from Hamlet into master, so master contains all the work I've done so far. The first thing I need to do is switch over to master, and that's using git checkout master. It's even telling me my branch is up to date with origin master. As far as it knows, nothing else has taken place on GitHub that makes this local version differentiate from GitHub. That's cool. But what I want to do now is merge in all the commits from the Hamlet branch. And that's actually quite simple. Git merge Hamlet. So, if I'm not mistaken, what I've just done, oh no, never mind. Yeah, so what I've simply done is taken these two commit things from Hamlet and stacked them right on top of my current one, which is kind of a best case scenario. Master is older, Hamlet is newer. You simply put stuff on top of master and you're done, right? You're just stacking up that main branch with more and more commits. And now that I'm done, I can run git push because my branch is ahead of origin master, that is to say GitHub's version, by 2 commits. So if I ever want to put the latest changes online, I can just do git push. That's it. And now it's uploaded versions 90E6 blah 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 to 00D5 so and so. Here's 90 blah 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 and 00 blah blah blah. All that stuff has been pushed to master on GitHub Origin. So if I switch over here, go back to Shakespeare and take a look at master, there's Hamlet. There we go. If I were to go back to Hamlet and try to compare the two or something, there isn't anything to compare because master and Hamlet are identical. They both have the exact 4 commits that I've done. So if I wanted to, I could now delete Hamlet. Not the file, but the branch, because that branch is dead. I don't plan on making any additional changes to it. Hamlet is perfect as it is. So I'm all done, right? So you'd think that, but let's talk about sort of a worst case, not as great not as good case scenario, and then we'll wrap up pretty shortly after that. Let's say that two people, that Shakespeare wasn't actually one guy, it was actually a group of people all writing plays. Crazy idea, I don't know, it might be true. Anyway, let's say that one guy was working on their own branch. Let's call it Hamlet. Oops, sorry. If you want to create a new branch, you have to check out -b, Hamlet. Right? So let's say that this Shakespeare person has decided to make some changes to Shakespeare. So now all of a sudden Hamlet is going to be Hamlet. Cool. There you go. That's all the changes I'm going to make. Meanwhile, so great. Now that I've done that, I'm on branch Hamlet. I'm going to go back over here. Great. I'm going to say git commit -am, change Hamlet's name to Hamlet. Great. In the meantime, someone else is on branch Hamlet. And check it out. All those changes I just made, not there, right? Because having checked out a different branch means that only the commits that live on that branch are represented here, right? And that change to Hamlet only happened on the Hamlet branch, so I don't see that here. So in the meantime, I'm going to go like, alas, poor skull, you're gross. Okay, great. So I just made a change here as well. I'm going to do a git commit. I'll make sure I'm on the Hamlet branch, the original one. Git commit -am. Hamlet finds skulls gross. Okay, great. You see where disaster is brewing here? I just made two different changes to the same line. So let's figure this out. I want to merge Hamlet and Hamlet into master. I have to do one at a time. I have to choose which one to do first. It really doesn't matter which one I choose. So let's do one first. Let's do git merge Hamlet. That should take all the commits that are not in master and merge them into master from Hamlet, right? Great, that worked. That was fine. Take a look at Hamlet here, and he thinks skulls are gross, right? Now, I'm going to do a git merge Hamlet and conflict. Merge conflict in Hamlet.txt. Automatic merge failed. Fix conflicts and then commit the result. So this is where Git's magic goes away. Git does the best it can. Every commit is not a new file. Every commit is not a full list of every single file in your system. All it is the lines that have changed, the insertions and deletions that have happened in different places. So Git is very good at trying its best to merge two different things. If two different people had even been working on the same file, but one person worked in one place and one person worked in the other place, that's okay, because they're working in two entirely different parts of the file. But if they both touch the same line, you're going to get something that looks like this. That's weird. Look at all these brackets, chevrons. Head, and then Hamlet, and then equal signs. It's kind of showing, you can kind of guess what's going on here, right? It's showing you that there's a conflict here. You need to choose between this one or that one. Or you can do what only humans can figure out and combine the two, right? This is one of those things that a machine cannot understand, because with Git, it's the entire line that's changed, even if you changed a single character. So you have to decide what the proper response is to this. And of course it is this. It's just changing the soliloquy and changing the name. And as you can see up here, there were no problems, because in the Hamlet branch, we didn't change Hamlet's name, right? Up there at the top, the name of the play. So There we go. We save it. We take a look at git status, and it says you have unmerged paths. That means that you're in the middle of trying to solve some stuff. Both modified. Path number 1, Hamlet, and path number 2, Hamlet, have both been modified. And so if we want to go ahead and fix them, we'll say git commit -am fix merge conflict, or whatever you want to say. And now we'll see that this commit changed Hamlet's name to Hamlet. This commit says Hamlet finds skulls gross. And this one fixes the conflict that originated from both of those things having changed the same thing. By the way, if you do a git log and it scrolls you off the top of the screen, you don't know how to get out of that, try pressing Q. Quit. So let's go ahead, now that I'm back on master, and push. And now, Hamlet has fixed merge conflict. We'll take a look at it. Hamlet, you're gross. History. Look at all the commits, and there you go, right? So that's it. That's how to fix merge conflicts. That's how to merge stuff from different paths into a single path, master, or whatever. You don't necessarily have to merge stuff into master. You can merge one branch into another and then into master, or never merge it at all. It's up to you. One last thing that I want to tell you guys about. It's called forking. Forking is how you contribute to open source libraries. You don't have access to my library, Shakespeare 10. Sorry, you can't go onto it and make changes to it. You can download it. Something I should have mentioned, you can clone repositories from GitHub. You can go here and you can copy this, and then you go into your terminal and you type git clone so-and-so, and it's going to don't do this within, please do not do this within this folder because it's going to download a repository into this repository. You don't want that. But git clone is the command that allows you to download a repository from somewhere, and it sets that up as a local repository. And it sets up the thing you downloaded it from as the upstream. The only problem is you don't have access to my upstream. This is a project that I created, and I'm not going to let just anybody make changes to it. That would be anarchy, which great for NoiseBridge, not great for right now. So without making all of you contributors to this library, giving you actual write permissions to my repository, how can you contribute to this? Well, GitHub has a solution for it. It's GitHub specific, and it's called forking. With forking, this is a little thing that you'll only see if you have multiple organizations you can fork to. But forking creates a carbon copy of my repository at a certain commit, at whatever commit you forked it. And now it's been moved over to your username. Now you have a project called Shakespeare 10. Maybe Shakespeare 10 2 because you already have Shakespeare 10, or Shakespeare 10 underscore, or whatever it did. Either way, you now have a version of my repository that you can make changes to by forking it. And when you make those changes, when you fork, I don't want to fork to my company. They're going to be mad about that. I can't fork to those guys either. Well, this is what I want you to do. Fork my repository. Sounds vulgar. Clone it by doing a git clone this. Do it in some folder that's not inside your current Git repository. Go outside of the Git repository you created and go back to your main code folder or something. But download it. Now, what I want you to do is make a change. Change the names around. Add an actual public domain Shakespeare play into this thing. Do whatever you want. Commit it. Push it back up to your fork, which should be automatic. Should already be set up to do that since you cloned it. And then what I want you to do is press new pull request. And then you can choose your master base, and you should be able to choose my repository from this screen. I want you to merge from your master or whatever branch you've created, and ask to merge it into my repository. And so I will potentially accept it. To be honest, I'm probably not going to accept any of it because that's going to cause massive merge conflicts because everybody's going to want to make changes to the same lines. And if I merge one person's stuff, then I'm going to have to tell everybody else in the class, sorry, go back and make the change so you can do it again. But that's unfortunately just the way that the world turns, right? Like that's how a lot of open source libraries work, where a lot of people are trying to make the same change, and it just so happens that it's moving so quickly that they need to keep their stuff up to date, their pull requests up to date, so it can actually be merged in. But anyway, if you do that, then I will see it show up here. You will also be able to see it show up here at jeffrey.tw/Shakespeare10. And I'll just go ahead and give you a thumbs up and tell you did it. Thanks for your contribution. I'm not actually going to accept it, but you know, you'll see how the whole process works. And all that's left is I just press the merge button and your changes get committed or not. But that's pretty much it. That's how you contribute. You know, I don't really want to get any further. It's nearing 10 p.m. I don't really want to get any much further into like proper etiquette and, you know, making your first contribution to an open source library, which I highly recommend you do, because getting involved in the community, being able to improve other people's stuff, it's a great learning experience, great way of putting your name out there, great way of learning just how to be a good coder. But you know, there's a lot of etiquette in terms of updating the README in case it needs any updating, providing tests to go along with your code, automated tests that can run and tell you whether you've broken anything. There are a whole bunch of different things, a whole bunch of intricacies, which I'm sure you can learn as you start to become a better coder. And of course, there are guides out there. I think that there's like a Learn Git. Is it called Learn Git? Try Git tutorial. And this is an official Git tutorial by GitHub that helps you learn how to do certain stuff and probably even walks you through pull requests and stuff like that if you need any additional help. So this is a great way to go from here. This is not a real command line. It's just a fake one on this site, but it runs very much like an actual command line, right? Oh, never mind. Did not create a Git because that's the only thing you're supposed to do on this screen. Anyway, there you go. So that's it. I'm going to have a lab on Thursday. My assignment for you, if you haven't already done it, is to create a pull request for changes that you've made to my repository and just send them my way. That's pretty much it. But I am going to have a lab regardless of there not actually being an actual like written down, you know, solution thing assignment. It's going to be on Thursday at 7 p.m. as usual in the class right behind me. Please, when you come, feel free to sit and answer any question, ask any questions that you have. You can work on previous assignments. You can work on your own stuff. I'm there to stand up and write on a whiteboard or walk you through whatever. So, you know, please make use of it because I think it'll really help you out. And of course, if you want to learn about future classes and future assignments, as usual, click one of these things, sign up, subscribe, and finally, donate to NoiseBridge. It's easy. Cool. Or don't click the or button because you'll see an image called or. Yeah, cool. Anyway, there's that. Cool. So really quick. Oh, look, a lot of people just were asking stuff. How do you see your directory that's based in its name? I already answered that question, and he answered that for you. Compare working directory changes in staging area and git diff. Oh, yeah. Well, if you made any changes, you can go git diff. There's nothing in diff. Diff is that differentiation. You'll be able to see a command line version of what's been changed since you committed. You know, so that's kind of helpful. Sorry, but I didn't able to get to these changes. I'm sure you guys saw everything you needed to see. Thanks for coming. See you guys later.